So how do we do Gauss-Jordan elimination? So what we're going to do is use those different modifications to the matrix to reduce it down to as close to the simplest form of the matrix that we can make. So 2, 4, 4, 12. How do we reduce this down? So for example, we're going to divide the first row by 2. Doing that finds 1 over here on the left. This is known as a pivot. It's something we can use to reduce down other components to 0. So doing that, we're going to reduce the bottom left corner of this matrix to 0. We're going to subtract 4 times the first row from the second row. This brings the bottom left component to 0. It brings down the 12 by 8 to 4. We're going to then find a pivot in the second column. That's going to be 1 once we divide that 4 by 4. We then get 1. We can then subtract 2 times the second row from the first row, giving us 1, 0, 0, 1. Another example. So we have the matrix 3, 6, 9, 2, 4, 8. So what I'm going to do is multiply the first row by a third. This gives us 1, 2, 3 on the top. What I'm then going to do is subtract 2 times the first row from the second row. That gives us 0, 0, minus 1 on the bottom. I'm going to multiply this row by minus 1, which gives us 0, 0, 1. I can then subtract 3 times the second row from the first row. That gives us 0 on the top. We're left with 1, 2, 0, 0, 0, 1. The 1s are known as pivots, and the 2 is known as a free variable. This matrix here is in reduced row echelon form because no further simplifications can be made to this matrix. Finding the inverse of a matrix. So take 2 to the power of 1. That's just 2. 2 to the power of minus 1 is a half. So that's our inverse of 2. Similarly, a matrix A also has an inverse, but it only has an inverse if the determinant of A is non-zero. So we need a square matrix. So take this matrix and place the identity matrix to the right. So what we're going to do is use 1, 2, 4, 12. So we're going to place 1, 2, 4, 12 on the left and the identity matrix of size 2 on the right. We're then going to reduce this matrix down to reduced row echelon form. And once we do that, we're going to have A, B, C, D over on the right here. That's going to be our inverse. So what I'm going to do is I'm going to subtract 4 times the first row from the second. Doing this, I get this here. I'm then going to divide the second row by 4 so I can get a pivot here. Once I have this, I can then subtract 2 times the second row to get rid of this 2 above. This gives us, we have the identity matrix on the left hand side, and we now have the inverse of 1, 2, 4, 12 on the right.